Welcome back to another CAD/CAM tutorial. In this video we are going to look at how to create a crank slider mechanism using SolidWorks. The parts of the mechanism are the bushing, the slider, the collar, the connecting link, and the crank disc. So rotary or rotational motion in the crank disc will be converted into reciprocating top and down motion of the slider, as we can see here. So this is what we are going to create today. Very simple to do, but it may look complex. Don't worry, I'll take you through everything. As usual, I have divided this tutorial into 3 parts. You have to check them all out. The first part, which is this video you are watching, looks at modeling the components that we have seen. We model the individual components. In the second part, we add mates and relationships between the components to form the final assembly. And in the third part, we do the motion study and add the motion just like we see over here. We are going to be doing all these with the help of these dimensions here on each component. So make sure you watch the video to the end so you know how to create this crank slider mechanism using SolidWorks. And don't forget to smash the like button, subscribe, and turn on post notification so you get an alert anytime I upload a video. And also share the video to your colleagues so they can also learn from it. And without wasting time, let's start. So we're going to start off in the SolidWorks window. I'm going to create a new parts file, and we start off with the modeling. This is our SolidWorks window. Under the features tab, we have the features and commands, and also under sketches, we have all these tools to help us with the sketch. So let's start with the first part, the bushing. The bushing is a hollow cylinder, so it's very simple to create. I'm going to draw 2 circles and extrude with the length of 80 millimeters. So create a sketch on the front plane. We need 2 circles with diameters 22 and 15 millimeters. First, we extrude the outer circle by 80. So come to selected contours and then click on this circle. Okay. Drop this down, click on the sketch, and this time extruded cut. You want to start the cut on this face here and then cut by 70 millimeters. So we start from the surface or plane and then click on this surface, direction 1, blind, and 70 millimeters. And then we come to selected contours and then click on this inner circle. Okay. We have a section view for the right view, and this is what we have. Very similar to this section view we can see here. So you're going to add color to it. Come to edit appearance and change the color to this and save it. So in the desktop, you create a new folder as the crank slider mechanism. This will be the bushing. We move on to the next part. the color. This color looks like a magnifying glass feature. So create a sketch on the top plane. We have 2 circles. Outer diameter of 25 and an inner diameter of 15. Extruded board base, and the height of extrusion is 12 millimeters. Okay, so we extrude via the mid plane so that the sketch or the part can be symmetric about the top plane. Okay. Now we add this cylinder to it as well. So create a sketch, this time on the front plane. We have a circle in this middle here, and the diameter of the circle should be 10 millimeters. Extruded board base, and we want to start the extrusion at a distance of 20 from this center where the sketch is, and then we extrude till it hits this surface. So from offset of 20 and direction 1 blind, and then reverse it for it to come this way, or you can just set it to up to surface and click on this surface. Merge results and okay. That is it for the color. So we change the color as well to a lighter gray color, or a lighter gray shade. Save it as the color, and then we move on to the next part. The connecting link. So we create a sketch on the front plane. First have 2 circles of radius 11 for the outer and a diameter of 10 for the inner. Since the radius of the outer circle is 11, the diameter will be 11 times 2. For this area here, I'm going to have a rectangle. So I'll place this center on the origin here. So hold the shift key, click on the 2 points, make coincident. The length is 14 and the width, which will be from this center to this center, is 51. Then we have another rectangle here. So again, draw a rectangle, and let's dimension. The length is 25 and the width is 18. I'm going to make sure it is symmetric about the midpoint, so hold the shift key, click on these 2 points, and then make vertical. The distance from this point to this center is 44, so I'll do that. And you can see the sketch is fully defined. I have a circle inside of diameter 10. Since this is 51, the circle should be here, and the diameter of 10. And finally, we'll have 2 inclined lines that meet at the top here like this. So I'll add them here, and we make sure the meeting point here is symmetric, or is in the middle of the part, So hold the shift key, click on the point and locate any center, make vertical. Now the total height is 75. So from this point, and then hold the shift key and click on this circle to select the outer, and this is 75. So the sketch is fully defined. You come to extruded boss base, and the thickness is 5. So you already know the areas to select to form the shape. Selected contours, click on the areas. We make it symmetric, so we use the mid plane. Okay. There are fillets here of radius 20 on all the sides where there are fillets. So with the constant size fillets and a radius of 20, click on where there must be fillets. So there is a mistake here. This thickness is 5. Come to edit feature and let me change it to 5. Okay. So this is the connecting link. You add a color. Save the parts. And move on to the next part. The crank disc. So create a sketch on the front plane. I have 2 circles first, and then one over here as well. So the outer circle is 50, the inner is 14. This is 10. This distance is 16, and make sure the circle is in the center. Now extruded boss base. First we extrude this area by 8 millimeters. So come to selected contours and then select this area with this circle. Change this to 8. Okay. Drop down, click on the sketch again, extruded boss, and now we extrude this by 18. So selected contours, click on this circle, change it to blind by 18. Merge results and okay. Change the color to a dark one. So this is fine, and save it as the crank disc. We move on to the last part, and that will be the slider. For the crank disc, I'm going to make the color a bit light. Then we move on to the slider. The slider is just a cylindrical rod, so create a circle on the front plane. The diameter of the circle 15, and then the length is 150. Extruded boss base by 150 millimeters. Okay. Then there is a fillet of radius 3 millimeters. On this edge. Okay. Give it a dark color. And save it as the slider. I'll go back and change the appearance or the colors for some of the parts. And here we have modeled all the components that we need for the crank slider mechanism. That will be it for this part of the tutorial. In the part 2, which will come right after this, we are going to add the meats to form the final assembly. So I'll see you in the next part. In the previous video, we modeled all the components needed for the crank slider mechanism with SolidWorks. In this second part of the tutorial, we are going to create the final assembly. So, create an assembly file. And then this is the assembly workspace. Since we have opened all the parts here already, there is this menu here that contains all the parts that have been opened, where we can just click and then drag. If you do not want that, you can close this. And to insert a component, come to insert components to bring back this menu. You can use the browse to go to any folder that contains your files if they are not already opened. Since my files have already been opened, I'm going to just click on them and then add them directly here. The first component I'll add will be the crank disc. Click on it, and when you move your mouse here, click. By default, when you add a component, the first component will be fixed. So right click and then float. So you can click on it and move it. We want to fix the crank disc in such a way that it only rotates about a fixed axis. Now, to fully define or fully constrain a part so that it doesn't move, we need 3 mates. Since we want to move it along just one axis, we are going to add just 2 mates. So the first mate, you come to this mate command. You want to meet the origins, which is very important. So the origin of the assembly workspace and then the origin of the crank disc. You can see the align axis here. Uncheck it, because if you check it, it's going to make it fixed. So uncheck the box and then okay. That is the first meet. The second meet, I want to check the degree of freedom, so you can move it here. We don't want that. So we want to also align the front plane of the assembly workspace. We want it to overlap with the front plane of the crank disc. So now when you click on it, you only move in this direction. So this is what we want for the crank. So okay, and we insert the next component, which will be the connecting link. So meet, and then this face and this face. Okay, and then this and this should also coincide. Okay. I'm going to insert the third one, which will be the collar. The collar, we want to rotate it about the y-axis so that you can enter in this hole, and then use the mate to align this hole and this shaft. Okay. Now rotate and then click on these two faces for them to coincide. Then the slider will enter here. So insert component, set the slider. We want to make the slider vertical, so rotate about the x-axis and insert the slider into this hole. Okay. Now I want to set a distance between these two faces. So come down to distance meet this face and this face. The distance should be 50 millimeters. Okay. Now let's try and move the crank and see. This is what we have. Now we make sure the bushing will be at the top here so that it will constrain the slider to move only in a top bottom motion. So insert the bushing. Again, rotate about the x-axis to make it vertical. And then we want to meet the whole of the bushing and then this shaft or this slider. Click on the slider and then this hole. Okay. Now you have to set some distance to fix the bushing at the top. So the distance between the top plane of the assembly workspace and this face of the bushing, I want to set it to 10 millimeters so that it comes downwards. And then the third meat we'll add to the bushing will be that you make sure the right plane of the assembly workspace coincides with the right plane of the bushing so that it will be in the middle here. Okay. Now we check the motion again by rotating the crank, and this is the kind of motion we want for the crank slider mechanism. So this crank slider mechanism is very useful in machines or devices that require reciprocating motion. An example could be a sewing machine. So yeah, this is the final assembly of the crank slider mechanism. That is the end of this part of the tutorial. In the last part, which will be the third part, we'll add the motion steady. So I'll see you in the next one. Save this, rebuild and save the document as the final assembly. In the previous video, we created the assembly for the crank slider mechanism using SolidWorks. In this video, I'm going to add the motion steady and then give it a rotary motion and let it run for us to see. So to do that, you come to the motion steady down here, or you click on the new motion steady, and you're going to use the basic motion this time. Set the type of steady to a basic motion, and you come to settings and make sure this is 60 frames per second, and then change all these to high, and that will be okay. Now select a motor, and then for the components that will drive the mechanism, select this face of the crank. I want it to run in a counterclockwise direction, so reverse direction, and then a constant speed of 100 revolutions per minute. This will be okay. And then bring this here, click on this, and we take it to 8 seconds for enough time to run the mechanism. I'm going to bring this down and then make sure this is set to normal for the playback mode, and then drop this down, calculate. After calculating, you can see the motion works, so I'll set the playback to loop and then play from start. So this is the crank slider mechanism, which converts rotary motion in a crank disc to a reciprocating motion in the slider, as we can see. You can change the speed to 1.5 or even make it times 5, or we can slow it down in any way we want. So yeah, this is the crank slider mechanism that we have created with SolidWorks. I hope this video helped you out very well. If it did, make sure to like the video, subscribe, and turn on post notification, and also share the video to your colleagues so they can also watch it and learn. And I'll see you in the next tutorial. Safe.